All right, ladies and gentlemen, welcome to the third and final video for Chapter 4, Section 2 in your textbook. This video will cover the exterior angle theorem, as it is a useful shortcut theorem when we are solving those advanced questions with lots of missing angles. Now, in order to do this, we do need to cover this vocabulary word, exterior angle, and we need to have a discussion about what that looks like. So it says it's an angle formed by extending one side of a triangle. When we say extending, what we mean is we take one side and we make it bigger. Okay, see how we've extended that out and made a new line segment? That has formed this angle right here. This angle is an exterior angle. Now, more importantly than the fact that that is an exterior angle, all three of the angles in the picture itself originally, all three of the triangle angles, which I'm now color coding as purple and blue with stars, have relationships to this red angle. The purple angle is adjacent to the exterior angle. And even more so, it's part of a linear pair, so it's also supplementary to that exterior angle, which is a useful bit of information, but it's not going to be the focus of our new theorem, our shortcut theorem. These other two angles will be. These other two angles are known as the remote interior angles. They are the non-adjacent angles in the triangle to the exterior angle. And they're going to be the focus of our theorem. Okay? Theorem is relatively simple. It's known as the exterior angle theorem. And it states rather simply that the measure of any exterior angle in a triangle is equal to the sum of those two remote interior angles. So in the picture, you notice angle 1 is the exterior angle, and angles 2 and 3 are the remote interior angles. This theorem is stating that the exterior angle, which is angle 1, is equal to the sum of the two remote interior angles. The measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. Now, as with any theorem in geometry, we probably should provide a proof to that theorem, so I am going to provide a 6-step, 2-column proof for this theorem here on the next slide, again to prove that it is in fact a rule, and then it could be used to prove other rules down the road. So here we go. Here is a proof of the exterior angle theorem. We are given that BCD is a triangle, and we are given that AC is a line segment. Those are the givens. Now, those are kind of strange givens. They're not even really statements. So here, let me explain to you why they're giving you those pieces of information. They're telling you that BCD is a triangle to cue you into how to start. That should cue you in to the fact that we're basing this off of the angle sum theorem for triangles, which says that the measure of the three angles in that triangle, angle 2, angle 3, and angle 4, have to add up to 180 degrees. As for the other given, that AC is a line segment, the reason they're doing that is they're trying to make sure you know that A, B, and C are collinear, and more specifically that angle 1 and angle 4 form a linear pair, which means that according to the supplement theorem, which says all linear pairs add up to 180 degrees, that the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. Now that we have two equations, we can plug one into the other to acquire this statement that we're being asked to prove. This is relatively simple. We're going to take 2 plus 3 plus 4, and we're going to substitute it for 180 degrees. That would generate the equation measure of angle 1 plus the measure of angle 4, which is the left side of statement 3, equals the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. We're substituting this in for 180 degrees. So we're taking the 180 out, replacing it with 2 plus 3 plus 4. Angle 2 plus angle 3 plus angle 4. Step 4 is a substitution step. Again, that is a straight up substitution property step. The next step says we're going to subtract. So we need to look at the equation we have in step 4, and we need to realize that we have the measure of angle 4 on both sides, which means we can subtract that off. Now, in a proof, that does take 2 steps. First, we have to show the subtraction, measure of angle 1 plus the measure of angle 4 minus the measure of angle 4 equals the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 minus the measure of angle 4. First we show it, which is the actual subtraction property step, and then we carry out the simplification. Notice that the measure of angle 4's drop out of that equation on both sides, leaving what we were trying to prove using the substitution simplify. Substitution, simplify. Using substitution property to simplify the 5th statement into the 6th. What we've done there is we've now proven that that is true for every exterior angle. Anytime we extend any side of a triangle, we can then use this shortcut to cut through these steps if we need to. That does it for Chapter 4, Section 2. Thank you very much for your attention. Our next set of videos will cover congruent triangles.